Good morning. Can you guys hear me? We'll wait here a few seconds for everybody to join. Well, once again, this is Getting Schooled, the sixth episode that we've done. And if you are just tuning in right now and trying to figure out what is this live video, I haven't seen this before. I'm meteorologist Ross Selt here at 13 ABC, and we've been doing these little school lessons, basically virtual school weather talks here over the last couple of weeks, and we'll keep doing them for the next 7 weeks if kids are out of school. Definitely we'll keep going all the way to early May with all these different topics. But today, talking about earth science and wildfires in particular. Like always, let me know if the audio is working. That would certainly be helpful here. And let me go ahead and get everything loaded up on my end to make sure everything is good to go. And then we'll get started here in just a few seconds here. Let me know where you're watching from again today. All right. I'm pulling it up here. All right, sounds good, looks good. So this is Getting Schooled, and we've been talking about earth science this past week, and even though that's not directly related to weather, there's been some weather-related themes in there. We talked about lightning that happens in volcanoes, so we mentioned that. Today, we're going to talk about wildfires, but also we're going to be talking about fire-nados. It's a real thing. It's a fire tornado. Yeah, we're going to show you some video on that coming up here in just a bit. By the way, if you were going to have been watching us, you're going to be watching next week. I did want to bring you up to date on what we're going to be talking about, because over the next couple of weeks, this is going to be a fun couple of weeks of lessons that we're going to be doing. We're going to be talking about next week weather technology. Monday will be radar and satellite, looking at the different things there. As meteorologists, we talk about computer models a lot. We'll explain what they are. We're going to actually go through computer models. I'm going to show you some websites. I'm going to show you guys where you can look at some of these computer models and what they mean and what they help to tell forecasters. We are going to go on Wednesday. Look at this. This is a weather balloon. And we're going to talk about why this is so important to forecasting and also different observations. That's going to be next week, but this is all setting us up for the week after that, because I'm going to try to do my best to teach you guys some simple forecasting techniques. And then for the kids that are watching, so not next week, but the week after, we're actually going to go through and do a forecast together, and then we'll do several days, and you guys will write your own forecast down together. And then when we come back the following week, we'll see how everybody is done with it. So we'll have some fun with it. But again for today, we're talking all about wildfires. Why do wildfires happen? Well, you got to have several ingredients together. So I mentioned this with tornadoes and hail, that we need different ingredients together. Like if you're going to put cookies together, you're going to put peanut butter cookies together, well, you got to have peanut butter. That's kind of important. Chocolate chip cookies, you got to have chocolate chips, and you got to mix everything together. You got to do it at the right time. We are very fortunate that we don't have to deal with wildfires in this part of the country all that often. It's a different story out west. They don't get as much rainfall. It's really dry. They have some mountains there. They got low humidity. They typically have wind racing down some of these mountains, which is really important to spread these wildfires. And then when you get some lightning, and even though it doesn't rain a whole lot, they do get these thunderstorms, but they don't have a whole lot of rain with it. But they get the lightning, and that can generate fires. They need fuel. When I mean fuel, I'm not talking about gasoline. I'm talking about like dry, dead trees and grass and stuff like that, stuff that can burn really easy. And then oxygen, which we think about oxygen being all around us, but when there is all that air that can help support these fires, and if you get a wind that kind of pushes into it, really helps to kind of fuel them and get them going. So I mentioned fuel. It can be brush and grass and dead trees. That's certainly a big fuel source for those fires. And then a lightning strike can kind of get everything going a lot of times, but if there's a lot of campers, if they're not being responsible with their fires, sometimes that can start them. Believe it or not, there are people that will try to intentionally set forest fires, which is called arson. It's a horrible thing, but if you get a fire to start, if it's raining out or if the grass is really wet, usually it's not too big of an issue. It just kind of fades away. But if you get strong winds to develop and lightning to go, well, then that fire takes off, and it can race up mountainsides, down mountainsides, and it's usually driven by the wind. And that can be a real problem for those folks that live in that part of the country. Now, it's interesting because for us, when in, say, November and December, when we get cold winds that develop, it's some of the first really big blasts of cold air of the season. It's that same weather system that can generate wildfires out in California. They get what are called the Santa Ana winds. And already things are usually very dry. And you get these strong winds that go down. And when you push air down, it compresses and it heats up. So it's like the opposite of making a cloud. When we have a cloud and the air has to rise and it goes up, that air condenses and it turns into the clouds that we see. If the air is going down, it heats up. It's totally different. And hot, dry, fast winds is usually a bad situation for wildfires. So I'm going to take you over. I'm going to show you some images here, and let's see. We'll start off with a really big wildfire. This is out. This was the Camp wildfire out in California, and it's not camp because it was started by a campfire necessarily. This was actually the term that it was given because it was close to an area out there called camp. So that was the reason behind it. But the image here on this part of the screen, this is a satellite image that shows you could see this wildfire. It was so enormous, so massive. You could see it from space. You could see the smoke developing, but you can see the flames there, all the red there. That's that main fire line as it was really getting going. This was a devastating fire, and it spread so fast for those folks that were out there, unfortunately. So it was just a devastating situation for them. But to talk about the science of wildfires, wind has a lot to do with it. You have to have the ingredients of dry conditions, like dry grass and trees and all of that. But then there are several different ways that these wildfires can spread. One is you get the winds themselves. The winds are coming in. You've got a fire here. It's going to basically push the fire right along the ground, and this fire is driven wherever that wind is going. In some cases, the wind will kind of whip up these flames here, and then you get little embers that'll be kind of floating ahead of it and will fall somewhere else and will start new fires, which is a huge problem because not only is the wind itself driving it, but these little embers might go anywhere and everywhere, and that's a big problem. And then sometimes, again, the wind is partially to blame here, but it takes this hot, dry air and it moves it out ahead of the fire, and then that dries all that grass there out in front of it and then causes more and more fires. It makes it to where that when that fire gets there, it rapidly spreads and takes off really quickly for us. So that's the science behind it of how these fires get organized. And then how in the world do you fight these fires? I mean, it's different if you're in a city and you've got a fire hydrant and you got a fire that's going on. The fire department just rolls down the street and they hook up the hose and they spray it down. In this case, you're out in forest lands, and here's our firefighter down here in this corner. Here are the fires kind of surrounding him here, and he's got, actually in this case, what he's got is something that will actually create fires. Why in the world would he do that? Why would a firefighter go out in the forest and make a fire when he's trying to fight fires? Well, if he strategically puts the fire in the right spot and it burns up all the fuel, and they can put that little fire out, as that other fire finally gets to it, it doesn't have any more fuel, it can totally burn out altogether. So these firefighters are sometimes fighting fire with fire to try to get everything to just fade away. That's one thing that they do. If they're trying to save certain towns, certain areas, that's the biggest thing they're trying to do. That's called fire lines, and also controlled burns. Controlled burns would be trying to burn off an area when it's not all that windy, that's got a lot of dry fuel, but they can take care of it and let it burn off. That way, when it gets windy and these wildfires get going, there's no more fuel for it to get going. But the other thing is, you see this airplane in this picture spraying all this stuff? Well, that is basically like a big extinguisher that's trying to put out the flames here. So airplanes and choppers, helicopters will fly over it and they'll dump this. Sometimes they'll even go down into a lake and in the mountains, and they'll scoop up some water, and then they'll take it and then they'll release that water where those flames are at. So there's a few different ways that firefighters will try to fight these fires. And sometimes it's with fires, and sometimes it's controlled burns, and other times it's actually trying to put it out. But when it comes to a fire tornado, so these fire tornadoes that form, this happens when it gets extremely hot. We had some questions last week. I remember some of you guys asking about not only tornadoes, how do they form, but there were some folks asking about a land spout. I remember that question coming in, and water spouts. I think I got asked that a couple times. And you guys were asking, how do these form? Well, it's because you've got a lot of instability right next to the surface, but you've got something, a little area that's kind of swirling around. But if you've got a lot of instability and the air is able to rise really fast, then it helps to stretch out that area that's rotating. And it's kind of like an ice skater bringing their arms and legs in. And when she does that, or he does that, they spin up really, really fast. So if you're ever watching ice skating and they're kind of swirling around in a circle, but then they bring in their arms and legs, you'll notice how they really, really speed up. Well, it's the same type of thing that's happening. When you start to stretch out that little area rotation and pull it up higher into the sky, it speeds up, and then it starts causing a bigger and bigger circulation. Well, this is, when you have a fire, it's extremely hot, right? Fire is hot. You get burned from it. You don't want to mess around with it because it can hurt you. But so because fire is so hot, you're talking about thousands of degrees, it's going to be much hotter than the air above it. So that heat is going to rise very, very fast. And what it does, if you get any little area of circulation, it's going to be able to pull that up. And as it moves skyward, it's going to help to swirl it up a little bit. So you can get some other conditions. It also depends on how the winds are blowing around that area too. But it starts off with, got to have the fire first. And then you get the hot air that's rising really quickly. And then as more hot air is pulled skyward, it begins to swirl because the atmosphere's tendency is to spin or rotate above a little axis. So it starts to spin just a little bit as it goes up. And then it's basically taking in all that fire, and then here it goes all the way up. You guys want to see a video of what a fire-nado is instead of just a picture? Let me see if I can get some videos up here for you of what that looks like. Let's go. All right. Let's start off with this one right here. This was... let's see, which one do I have? This is the campfire. So I don't think we're to the fire-nado yet, but I want to show you some video. Remember I showed you that picture from space, how you could see that? Well, this is from the video here of that fire itself. Oops. So you can see how this was a breaking ABC News story, but this fire developed so rapidly that there was whole towns that were trying to get out of that. And you look at what it did, what the aftermath of some of those houses that were there, barns, cars, all of that stuff, just rapidly burned up in the flames with it. All right, there we go. All right, now I'm going to take you over. Now this is Sam Champion, so Good Morning America. And then he's going to show, here we go. Here's one of these fire-nados. Take a look at that. I mean, that is a scary looking thing, isn't it? We'll let this video play out here. But you can see in this situation here, it's starting to go up, and now this is when it gets really intense, going straight up into the sky. There it is again. So I don't know if we're looking at different video, but you can see it kind of getting organized right here. Well, although there's not that guy. So this one, I believe, was in Australia. I've got another video to show you too. You see that big plume of smoke. There it is again, getting organized. And the winds around it, I mean, that is hot flames, but the winds are circulating right around it. Look at the bottom here of that. There it is one more time. And okay, this must be the Australia one. As we know, if you've been paying attention to the news, several months ago, Australia had some crazy wildfires down there, so it did the same thing. And these fire-nados typically happen in the most severe wildfires. It's not just a typical fire that'll do this. But you can see this one, there it goes, swirling up into the sky. Wow. It happened so fast, but the winds were just just right for that to all take place. All right, so I'm going to take you back over to the other computer here, and that's what we're talking about today with when it comes to wildfires. So that was really the coolest thing. I think those fire-nados are really, the science behind it is just really, really neat. But obviously wildfire is very dangerous. And thankfully, we don't have to deal with them here that often at all. And the biggest reason, it rains here a lot compared to what it does out in Australia or where it does out in California, where they get more of these fires. And we don't have the same mountains and we don't have the same winds that usually kind of help funnel all this stuff together. So over the last few days, we've talked about volcanoes, we've talked about earthquakes, we've talked about wildfires. All three of those, well, volcanoes would never happen here in this part of the country. Earthquakes are very rare, and wildfires are very rare, and they typically happen. It's usually more of like a brush fire that's gotten out of control that might burn up part of a field or something like that. So, you know, those two are quite rare. But go ahead and ask your questions here of what, whether it's anything we talked about earth science this week, or if it's, again, severe weather or some other weather question. Doesn't matter what, we'll get to it. Not a problem at all. So is Maria asking, was Ohio or has Ohio had any fire tornadoes? No, I don't think so. Not to my knowledge. I just don't think that we can get those ingredients here. Usually you see that more out west, out towards California. Can a fire tornado go as fast as a regular tornado? So it has to do with the winds that are around it. Typically these fire tornadoes don't last that long. They can travel a little bit, but and they just don't have quite the same wind speeds as an actual tornado would. So, and if you're talking about an EF3 tornado or something, you're not going to get like an EF3 fire tornado. Usually they happen pretty quickly and kind of run through their cycle and they're done with. But the thing is that you would not want to be anywhere near this. It's not the winds necessarily that are driving this or the winds inside that fire tornado. It's the fire itself that is really the biggest problem. Brandon asked, can there be a water tornado? Absolutely. They're called water spouts. And so in these water spouts, we have them on Lake Erie a lot. Actually, we have a water spout season, and it runs later in the summer into fall. It's not the springtime. It's not this time. We just don't get the water spouts. And the reason for it is that right now, Lake Erie's kind of cold. It takes a while to warm that water up. All that sunshine through the spring and the summer will warm it up. Now, water takes a lot longer to heat up or cool down than the air does. So now when we get into late summer, especially getting into fall, and the temperatures start to cool down, the water's still really warm. And if we get a big blast of cold air to come in, that water just can't cool down nearly as quickly. So now the water's really, really warm. And we know that warm things, warm air, warm water, that temperature, it likes to go up. It likes to rise, right? So if you've got warm water, it likes to rise and kind of mixes in. If you've got warm air, it wants to rise. And so as that air begins to warm up right next to the water, it rises really quickly. And then again, any little tiny area of rotation that's there, it can stretch it, it can speed it up. And these water spouts ended up starting near the surface of the water and then get stretched upward. And that's how they develop. Now, there was one video, and I wish I could find it to show you guys because it was fascinating. It was one of the more fascinating fire tornadoes that I can remember seeing on video. And it got developed, and it started off as just a massive fire. It didn't look like it had enough circulation to turn into a fire tornado, but it did, and it turned into a big one. But the thing is it was heading right towards a lake. And so as you know, as it gets to the lake, it kind of just died out in a sense, but then it turned into a water spout. It was the craziest video I think I've ever seen. Because you expect, well, it's going to get to the water, well, there goes the fire, and it did, but it still had that circulation, and it was still so hot compared to the air above, it actually turned into a water spout at that point. So just a fascinating thing. I don't think I've seen anything quite like it before. Let's see, some of the other... Can there be a wedge fire tornado? Kinsey was asking that. This video that I was referring to kind of look like a wedge fire tornado, but usually they're not. Usually they're like what I showed you. They look like a thin rope. Is kind of what they usually look like. How long did the largest wildfire last? Some of these wildfires have lasted a very long time over the course of days and even weeks. And really, sometimes your longest lasting wildfires are not your most intense, because if there is some moisture around, it can kind of burn at a slower pace as it's crawling along. And if it's out in the middle of nowhere where there's nobody living there, then you aren't necessarily going to have firefighters go out there and try to put it out. They're going to let it burn out if it's not threatening any towns or homes or people. So sometimes they can last a long time. But in that situation, again, it's nature's kind of just doing its own thing. If you get a lightning strike to start it up, and people are warned to stay away from the area, and it just kind of burns out and burns on its own. Well, let's see some of the other questions here that we've got. Let's see. Logan wants to know, can a fire NATO spin faster than 100 miles per hour? I would say it probably can. Typically, it's not that strong, though. Typically, you're probably 70, 80, 90 miles per hour. Very strong, but certainly causing a lot of, the damage is twofold. I mean, the damage is more from the wildfire aspect, not so much the wind in that situation. Can a fire NATO match with a normal tornado? I was probably not on that one. Samantha was asking that one. How big do wildfires get? They can become quite massive. Thousands and thousands of acres, which is taking up, basically be like the size of Toledo or the size of Lucas County or something like that. I mean, it can take up a large area at one time if they really get going. And a lot of times you have several wildfires kind of in a similar area that can get going. Where do fire tornadoes hit? In the United States, they happen probably more often in California than anywhere else, although Arizona is another spot where you've got a lot of mountains and you've got a lot of dry areas. And so if they can dry out, wildfires can get going there. We had a couple of years ago, maybe 3 years ago now, Glacier National Park was hit by a major one. We were actually, we took a trip out to Glacier National Park and visited there, and everything was fine. And then about a week later, they had a wildfire that shut down the whole park and kind of devastated that area. So it can happen really quickly. The Canadian Rockies was another spot that they got hit pretty hard. Washington, Oregon. So any of those areas that you start getting a lot of timber, a lot of woods, and then you're also in a mountainous area that doesn't get a ton of rain, is definitely a suspect to intense wildfires, and it's the intense wildfires that lead to those fire NATOs. Can a fire NATO be as large as a regular tornado? Depending on how big the regular tornado is, yes. A lot of times these fire NATOs are somewhat small and they're kind of long and skinny and go clear up into the cloud. When it comes to weaker tornadoes, you can have that. Now, sometimes when it comes to tornadoes, you can have a really large tornado and still it not be all that intense sometimes. You can have a small tornado and it can be really intense. So sometimes the wind speed is not the same or doesn't correspond with how large that tornado is. But you can definitely have a fire NATO that is as big as some of these small tornadoes. Same thing with the water spout and the land spout. They can all kind of be in that same range as the smaller tornadoes. And I think I mentioned this last week, but when we get microbursts, big damaging wind events, they can be as intense as smaller tornadoes too. So tornadoes can be small, they can be very large and very intense and have a lot of different varieties in there altogether. Let's see, what happens if the fire starts on a mountain and the fire NATO goes for a while? It's kind of like, in a sense, like a regular tornado. That tornado will last as long as you have the really intense ingredients. You got to have the right ingredients at the right time to come together. As soon as you start to get some of those things that are missing, all of a sudden you're not going to have the tornado anymore. And a fire NATO is the same thing. A lot of times you get a really intense wildfire. Even if it's on a mountain or going down a mountain, it may spin up a fire NATO, and that lasts for a minute or two, and then it kind of fades away, and maybe it spins up another one. But it can, the fire NATOs usually don't last nearly as long as a wildfire itself. You got to have the wildfire there to begin with. Can a wildfire burn down thousands of houses? Well, the whole hope and the point with these firefighters is that doesn't happen, but occasionally it does happen. And that Camp Wildfire, the one where I showed you the picture, the video, it was the first video we looked at, and also the picture from space, it wiped out there in Paradise, California. It just wiped out whole hundreds and hundreds, and I believe I don't know if it was thousands of homes and buildings, but it was at least hundreds, and it affected thousands of people. That was one of the most devastating wildfires that has impacted buildings and homes like that we've had in our country's history. And that wasn't that long ago, within the last couple of years that happened. Can a fire tornado burn a car? So it's not, we showed you that video of that lava like totally just erupting a whole car into flames. A wildfire isn't going to be as intense as that lava flow that flowed into that car, but it can certainly burn up the car to where you're not going to be able to use it anymore, to where the only thing you have is kind of a shell of metal left over, to where it burns the paint on the outside, it burns everything in the inside, so it definitely can. It's a good, okay, so we got a good question here. These are all good questions, but this is one that kind of makes you think a little bit more. Which is more damaging, a tornado or a wildfire? And so this is an interesting one because a tornado is really about the most intense type of weather feature you can have on this planet, but it doesn't happen over a widespread area. So, for example, I was just talking about the Camp Wildfire out in California that was so devastating, and it burned up hundreds and hundreds of homes. I mean, just everything that was there ended up burning up. I mean, everybody had to basically get out of town really quickly as that was coming in. So that did more damage overall than what a tornado would, unless it was a very, very large tornado. But typically, even if a tornado were to hit that town, it didn't do as much damage as that wildfire. So in that situation, the wildfire was worse because it affected a larger area. Tornadoes are more intense, but it happens over a smaller area usually. And by the way, I know we'll get this question later on when we talk about hurricanes, which is more damaging, a hurricane or a tornado. It's the same type of thing. Hurricanes do not create the type of winds that we get in an intense tornado, but hurricanes produce storm surge, they produce lots of flooding, they produce high winds over a large area. So if you look at the total amount of damage from a hurricane versus the total amount of damage from one tornado, a hurricane is going to be worse than that one tornado if you look at the amount of damage. But if you look in that certain area where the tornado hit, that damage would be worse. So that's a good question. And then how frequent do firenadoes happen? It really depends on how intense those wildfires are, and every wildfire season is different. If California's had a lot of rain in these areas that typically get wildfires, then they're not going to have much of a wildfire season. When they do get the wildfires, it's typically not going to produce those firenadoes. It's the seasons that they're in drought that it becomes even worse, that you get more wildfires. The wildfires that burn are much more intense, and then you get those firenadoes. So if you see a firenado, that means almost always that wildfire is extremely intense that has developed. And then another question here is, there ever been a wildfire in Northwest Ohio? The answer is yes. Occasionally we get what's called a red flag warning. A red flag warning is essentially don't burn anything outdoors because the conditions are right for wildfires to develop. They get red flag warnings out west a lot. We rarely get them. I think that we've had maybe 2 red flag warnings, maybe 3 at the most, definitely 2 though. Since I've been here in 8 years. So that would tell you about every 3 to 4 years we might get a red flag warning, which is not very often. And then when we have had a couple wildfires developed where it's burned sections, maybe somebody throws out a cigarette out the car and it burns up a stretch there on the side of the road. We've had areas where part of a field or something like that was burnt, but nothing to the significance like they have out west. Even when we've had those conditions where wildfires could develop here, it's never gotten to that point, and we just don't have the same environment or same setup that we've got out to the west. So I'm going to end it here, and then next week, so nothing tomorrow, nothing on Friday, but then coming up next Monday, Tuesday, and Wednesday, we're going to start talking about weather technology, and this is all going to lead up to how we forecast the weather. So if you're excited about putting your own forecast together, Definitely want to come next week because that's going to, while we're not going to actually be forecasting next week, we're going to start to learn more about the process. And then the week after that, we definitely are. So again, that weather balloon that I showed you earlier, this thing looks like a normal sized balloon. When this thing gets blown up and totally full, it's bigger than me. And then when it goes up into the sky, it expands and expands and expands even more. And this goes up thousands and thousands of feet into the sky. It'll hold a little box on it, which is a little weather instrument, and goes up. They've been doing this since the 1920s, 1930s. It is still one of our most important ways of getting weather information that we have today. So we'll talk all about that, radar, satellite, computer models, which I'll give you guys some websites and you guys can play around. And if you even want to try to do your own forecasting next week or try to get an understanding of how it works, and we'll give you some of those tools to do it. So look forward to seeing all you guys next week and answering some questions and talking more weather.